time for lucky number 7. In this lesson, we're going to learn about properties. So our criteria for success is to be able to examine the structure of an expression or an equation and to accurately determine and identify which of the various properties was used. So zooming back up a little bit, we're going to talk about a lot of terminology and just giving names of things that you've been doing with numbers for a really long time. Let's start with our first two properties, commutative and associative. And this is for both addition and multiplication. Here's how I tell the difference. When I think commutative, I think about the word commute, like my commute to and from school. If I'm walking the exact same way, it doesn't matter if I'm going from school to home or home to school, the distance is the same. So that's commutative. It's like a back and a forth. For associative, I think about who I associate when I'm in school. Like I have tons of different groups of friends, and sometimes I go to my friends that play sports first, and then I go and I say hi to my friends who are in my science class. So that's what associative means. Like these are just the different groups. Who do I go to first or second? And the order doesn't matter because they are all collectively my friends. You've been doing this in math since you were young. So for example, with the commutative property, I'm going to put some numbers here. It didn't matter what order. As long as I had two numbers, if I'm adding them, the order doesn't matter. So I can do 5 plus 3 or 3 plus 5. I can reverse those two numbers and it's still the same. This is easy when you think about it with positive numbers, but it's also helpful when you think about it with negative numbers and think about how many times you probably reversed numbers that were negative because it was easier for you to add them together. And the same thing is true with your multiplication. I can do 3 times 5 and I can do 5 times 3. Again, the order doesn't matter because I'm talking about groupings together. Now, with the associative property, this is where, again, visually, think 3 or more numbers, if that helps. With commutative, it's usually just 2. With associative, it's 3 or more. And with associative, again, it doesn't matter. As long as I'm adding all the numbers together, it doesn't matter if I'm doing 3 plus 6 plus 5. I can add 3 plus 6 first. I can add 6 plus 5 first. I can add 3 plus 5 and then 6. Doesn't matter. And think about how helpful that is when I'm rewriting equations. Sometimes I want to put certain terms together first in my work. So again, as long as they're all being added, I can do that because of the associative property. And that is also true with multiplication. If I had 5 times 10 times 4, I can make my numbers friendly and I can decide to do 5 times 4 first and then 10, so 20 times 10. Maybe you want to do 10 times 4 first and then 5. So you have that leeway with the associative property. Again, because all 3 numbers have the same operation. You're either adding all of them or you're multiplying all of them. So these are the commutative and associative properties for addition and multiplication. We're going to talk about the 2 I properties now, identity and inverse. These super important for working with equations. Really, really helpful because there are going to be times in equations where you want to keep the expressions the same value, and so adding 0 helps you to do that. Or let's say you're multiplying and you want to keep it the same value. How do you do that? Now that you're in high school, you're not always going to multiply by 1. This could be you're multiplying by something like 3 over 3. It's still equal to 1. You're still going to get a at the end because any number times 1, it's going to give it itself. So you get your own identity back. This is also going to be true for addition. Any number plus 0, you're going to get the identity back, the same value back. So these 2 expressions have the exact same value. These 2 expressions have the exact same value. So now that we have identity, which gives us, we see it back, let's talk about inverse. So also pretty important. For addition, this is where we think about our 0 pairs. and how sometimes we want to have 0 on one side of the equation. And a way to do that is to just add its opposite. So for example, and you've done this many times, if I had a plus 5 is equal to 8, I want this to be 0. And the way to do that is to add its opposite, negative 5. So this goes away and becomes 0. So that's where 0 pair is super helpful. And again, you've been doing this since middle school. So it just means add your opposite and you create 0. If I want inverse with multiplication, let's say I want to get 1 at the end. Also super helpful. I'm just going to multiply by the reciprocal. So again, you might be thinking, Sarah, why do I need to know this? Well, let's say I have 3a is equal to 10. I want this to just be 1a. So I can multiply by its reciprocal 1/3. Now this goes away. I get 3 over 3a, which is the same thing as 1. That is why it's so helpful to have the inverse operation. And we know whatever you do to one side, you're going to do to the other. So you're also going to multiply this side. So again, 2 properties, super helpful just for working with equations when you're trying to isolate your variables. Last one we've seen, to distribute, means I have even groups. That's all this means. I have even groups and we're going to multiply. So you've probably seen this as a bird beak method where you decide to do 3 times 4 and then you're doing 3 times c to get 12 plus 3c. We've seen this many times, but we're also going to see this a lot with array models because we won't always have easy numbers to work with. So I could also use a model to show 3 times 4 is 12 and 3 times c is 3c, and I can rewrite it. It's also going to be helpful when we're working backwards with factoring. You're going to see how I can show an expression using the distributive property. I can write it this way when I've factored out a number. We're going to see that in a few units from now. So that's the distributive property. All right, I'm going to do 2 models and then 2 quick guided practice ones. So in the first one, which equation illustrates the distributive property? So take a look at the choices, which one has a parentheses and shows multiplication by groupings. And the only one that does that is A. And you can see it very clearly up here in the front. I would have to multiply to get 5A. I can't choose C because I'm adding A to B and C. So it has to actually, that term has to be right next to the parentheses. Let's go to the next one. Which property is illustrated by this equation? So I have 3 terms, and notice with parentheses I'm adding 2 different terms here. So 3 terms, who do I want to be groups with? Who do I want to see first? That is the associative property. I know it can't be commutative because I have 3 terms, not just 2. I'm definitely not distributing. It's definitely not identity because I don't have the same answer at the end. All right, let's go to the next 2. What's illustrated by this one? 80.8 times 1 gives me 80.8. So I'm getting the same answer back. So this is an identity property. And obviously, because I'm multiplying, it is a multiplicative identity property. Okay, because I'm getting the same value. I'm getting my identity back to me. And in the last one, take a moment just to read the problem. We're going to figure out the reasons what property is used to solve. So looking at this one, I'm not worried about given. How do we go from this to this? What has to happen here? We're distributing. So all I would write is distributive. And for the second one, how do I go from 8a to 22a? If you're not sure, you'll also notice that for negative 14a and nothing is here. So I have a 0 here. So that is your big clue. I have a 0. That means they must have added its opposite to create a 0 pair. So this is the inverse property of addition. And they also added the same 14a on this side to get 22a. So that's it for today's lesson. We're taking a look at all these different properties, these different terms. And to be fair, this is so helpful because we get so caught up in order of operations and thinking we only can do things in one order. But we have actually a lot more flexibility with numbers that is super helpful when we're working with equations. We're going to get more into that in the next lesson. I'll see you next time. Be well.